All right, so the first line says simplify without a calculator, and the next line says simplify with a calculator. It looks like I need to line up some indents there or something like that. No, we're good. Okay, looks like we're good there. Let's see. Logarithms are asking a question. This one is asking 3 to what power equals 9? Answer's 2. Okay. And we'll close that. There we go. Okay, this one is asking the question 2 to what power equals 32? That one's a 5. 10 to what power equals 1,000? That one's a 3. Okay, now this one is asking e to what power equals 4? Okay, now that one you can't figure out without a calculator, but you could at least take a guess. What would e to the first power be? Roughly 2.7, okay? If I did e to the second power, let's round up and say it's 3. If I did e to the second power, so that'd be about 9. So it's going to be somewhere in between. I mean, in reality, 2.7 squared is probably 7 point something, okay? But this is going to be a number in between 1 and 2. What is it exactly? Okay, so 1.386. 3 decimal places of accuracy is usually pretty good. Okay, now if I write log of 121, this is asking 10 to what power equals 121. We know it's going to be bigger than, okay, 121 is bigger than 100, so our exponent that we'd put on 10 would be bigger than 2, right? But less than 3 because we already figured out 10 to the third power is equal to 1,000. So somewhere between 2 and 3, a heck of a lot closer to 2. And what is it? 2.08. Is that rounded correctly? Okay, 2.8, 2.083. Is everybody okay with that? Is that right? I don't have a calculator up here, so we're good. Okay, now here's the difference between these problems right here that you can do on a calculator, the problems that you can do without a calculator, and this one right here. This one is saying 3 to what power equals 4. So here's the issue, and this is why it has a star by it. Well, 3 to the first is 3. 3 to the second is 9. So it's somewhere in between there. And when we ran into a problem like that, we used a calculator to figure it out. But you do not have a log base 3 on your calculator. You only have, the two names are natural log, okay, ln, log base e, and the common log base 10, right? You don't have a log base 3 on there. So that's part of what today's lesson and section is on, is how can we figure out logarithms that have a base other than something on our calculator and get a decent decimal approximation for it, okay? So even though it seems like when we're dealing with logarithmic expressions, getting used to those, so that's a little bit weird. If they're just a different way to write exponentials, why not just leave it that way, okay? But they have some really cool properties, one of which is the fact that they undo exponentials. Now, we're already pretty familiar with that so that we can do problems like this. I mean, if this were a log base 3 of 3 to the 9th, we'd be done. Because this is a log base 4, this is an exponential base 4, so the answer's 2. This is exponential base 9 right here. This is log base 9 right here. They undo each other. The answer's 5. So it doesn't matter what the base of the logarithm is, as long as this is log base A and this is exponential base A, those undo each other and we have an x. Okay, they just undo each other. We get right back where we started. Plug an x into the exponential base A, take the log base A of that, we're right back where we started. Okay, they're truly inverses of each other. And it doesn't matter the order. Here you can plug x into log base A, then use that as an exponent on exponential base A, we still get x. So if I had something like this, again, it's not written here, but this is natural log base e, of e to the 4th. Answer? Piece of cake, right? And this one? Just x, okay? Now, those are some nice properties of logarithms that we're already familiar with, that they're inverses of exponentials. But here are 3 properties. Take a good look at those. Has anybody in here seen those before? A couple of you? Okay. All right, so logarithms have these really cool properties that they allow us to simplify the operations. This isn't such a big deal these days as it was maybe 50 or 100 years ago or maybe 1,000 years ago. Because when they were working with logarithms, if you don't have a calculator, you had to look things up in a logarithm table. Okay? Big books that had everything that was log base 2, everything that was log base 3. So maybe a separate book for each one of those. Logarithm tables take a long time to flip through, find the answer. You've got to copy it down and stuff like that. Okay? So if we have these properties that will allow us to simplify the operations, it's much easier. And this is the way it works. So the first property is called the product property. So if I'm taking the log base A of m times n, so I'm multiplying these two things together, and then I'm taking the log base A of that. I can write this as the log base A of m, and then add it to the log base A of n. They allow us to change multiplication into addition. So they allow us to change multiplication into addition. And usually these two numbers are smaller, easier to work with, probably easier to find in the logarithm table. Okay? So that was a heck of a lot easier. Get the numbers, add them together rather than figure out this huge number and then figure out a to what power equals that huge number. Now what I want you to notice is these properties work in reverse. This is an equal sign. If I have this, I can write this down. And if I have this, I can write that down. Okay? So if I have log base 4 of 5 times 3, I can write log base 4 of 5 plus log base 4 of 3. Yeah, and so thank you for bringing that up. This is one of the things that for a lot of people is a little bit difficult. Sometimes this is just mental exercise, okay? Algebraic mental hoop jumping, okay? Your answer on a lot of these is just going to be an expression. It's not going to be a number answer like you're used to getting, okay? So that's all. So they have instructions like write this as two separate logarithms, or write as a sum or difference of logs by the time we get done with this. So if I have the ln of x times y, I can write the ln of x and then add it to the ln of y. Now, the opposite is also true. If I have a sum of logarithms and they have the same base, notice that those would both be base 10, I can write it as one single logarithm and I can write the log of, what would this be? Okay, it'd be 4 times 9, so this would be, well, we can skip that step and just say log of 36 is about as easy as you can write that. So sometimes it's more convenient to use the property this way. Again, sometimes it'll depend on the instructions or the problem. And sometimes it's more convenient to write it this way because the numbers are smaller. Okay? Now, if logarithms allow you to change multiplication into addition, what do you think they change division into? Subtraction. So this is log base A of m minus log base A of n. So logarithms change division into subtraction. And again, I've got a phrase on both of those. Okay? Log of a product is the sum of the logs. Change multiplication into addition. Log of a quotient is the difference of the logs. One thing I want you to notice is the one that's on the bottom has the negative in front of it. I'll say that again, and that's an important thing to keep in mind. The one on the bottom has the negative in front of it. Okay? Intuitively, that might make sense. If you want to think ahead, we're going to dive into why this is actually the case. Logarithms and exponents play really well together, and you might want to think about the type of exponent that would show up in a denominator. Okay? So think about that for a second. So on a problem like this, log base 7 of 3/7. Now 3/7 is an ugly number, but let me just demonstrate this property. This is log base 7 of 3 minus, because we're going to write log base 7 of 7. 7 was on the bottom. Now even on this very simple example right here, can you see how properties of logs might get us closer to the answer and make this a little bit easier? What is this? That's a 1. So you could write this as log base 7 of 3 minus 1. At least you know one of them, and all you have to do is figure out what the log base 7 of 3 is. Okay, but this would be the answer as far as just writing it out using that property. Okay, if you came across something like this on the assignment, you'd probably cross that out and just write a minus 1 in its place. Okay. On this one right here, this is log base 10, so this is going to be the log of p minus the log of q. Again, notice the one in the denominator has the negative in front of it. And then again, it's an equation. You can use it this way or this way. It goes both ways. So here we were breaking it up and writing it as a difference of logs. This is already a difference of logs. I can write that as one single logarithm. Which one goes on the bottom? So this is 3 over 6, which I would write as ln 1/2. Okay? That's how we'd leave it. Okay? Again, they allow us to do some simplification there. Okay, are there any questions? Okay, let's take a look at the next property then. This is a really useful property, and it helps us figure out why that last quotient property works. This is called the power property. Extremely, extremely useful. Okay? We use this all the time. A lot of you are going to go on and take calculus. You'll see this used quite a bit. So the power property allows us to do this. It allows us to change an exponent into multiplication, or in other words, a coefficient sitting out front. So this becomes r times the log base a of m. So the log of a power is the power times the log. They allow logs change powers into, you can call them multiples, you could call them factors, okay? Whatever makes sense to you. You could call it a coefficient, okay? So I realize we've done problems just like this before, but take a good look at that. Log base 5 of 5 to the third, and let's use this property. This property says I can bring that out front. So this is 3 log base 5 of 5. Now, we know the answer is 3, but let's take a good look at this. This is using the property, and what is log base 5 of 5? That's going to be a 1, so this would be 3 times 1, and it would be 3. Does that make sense? Let's take a look at this. How could we rewrite this? Yep, slide this out front. Sometimes I'll even draw that little line there. So we've got 2 log base 6 of x minus 7. You would want to leave that in parentheses. That's how we'd write that. This doesn't get much simpler here, but we can use this property in the opposite order. We can take a factor out front and we can put it up here, and this becomes the ln of 2 to the 5th, which we would probably rewrite as the ln of 32, and that's how we'd write that. Okay? Last two properties, just a quick reminder. Log base b of b is, it's 1, because b to what power equals b? That would be 1. And the log base b of 1 is 0. Any number to the 0 power would equal 1. Okay? We're going to stop right there. I want you to go ahead and put that away. We're going to pick up there. I'll quickly review that tomorrow, and then we'll just plow